500. So that means that this problem is telling you might come up with decimals, but let's make sure we keep the same number of decimal places in the problem. So it's a case where we might not get a nice whole number out of the problem. Okay, so we need to set up our problem. Most important thing in the problem, what are they asking you to find? Right there. That's the most important sentence in the entire problem. I need to find out the number of hours for each firm. Why is that important? The things that we're looking for become the column headers when we set up our table. We know that we're going to have a table that's going to have some rows and it's going to have some columns, and the one solid foundation thing here is that the outside right-hand column will always talk about totals. So if we run into problems with difficulty remembering what goes where in terms of what words, concentrate on the total thing first. Then go back into the problem and start looking for the numbers that are involved. So they wish to conduct a survey, blah, 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 survey has 32, blah, blah, the company can handle 25. So we have a total of 520 telephone contacts. Those are all phone contacts. All the information on that line has to deal with phones. And 301 house contacts. All the information on that line has to deal with houses. So any other information in the problem has to be in the columns. So what specifically do we have for phone contacts? We got two companies. We have company A, the number of hours that they're going to be contracted for, and everything in that column is going to be associated with the next variable. And we have hours for B, and everything in that column is going to be associated with Y values. So any numeric value we have is a coefficient on the X and the Y term of the problem. So what's company A capable of doing? Company A can give us 32 telephone and 13 house contacts per hour. 32 phone contacts for every hour that they work, and 13 house contacts for every hour that they work. 13 didn't go on the top row because 13 would have had to go into the next cell, which means it's information about company B. And that's not what they told us up there. Company B is capable of handling 25 and 17 contacts per hour. 25Y and 17Y. And really what you have right now is your matrix if you pull out the variables of the problem. But if they want a system for the exercise, 32 hours, 32 telephone contacts for every hour, 25 contacts for every hour for company B should account for all 520 houses that need to be contacted. 13, that was X. I'm overthinking myself here. And 17Y better account for all 301 phone contacts or houses that need to be contacted. There's your system. And now that the system's set up, they want us to be able to solve the system. Here's where we come to cut to the chase. Do you really want to solve this system by hand? I don't. But you struggle with even coming up with a system, which is why this grid approach, this table approach, helps you organize the information because it gave you what the system looked like in the problem. And it also gave you the guts of what the augmented matrix is going to look like as well. So by using the table, you don't fight with all the words and go, where do I put this number? look for the words first. And really, this is the most important thing that's in the whole problem right there. Where are the totals? If you find the totals, then what do these totals describe? They describe phone contacts, they describe house contacts. Now we've got to have a label for this up here, and it's got to be, the only thing we haven't talked about here is company A and company B. If you put company A and company B out here, it's not going to be wrong, but your system's going to look very strange because it's not going to be set up the right way. Your totals will be in the wrong place. Your totals end up being down here, and now your system would look like this instead of like this, and that's not the way that matrices look. They look horizontal instead of vertical. So there's the setup for the problem. Now we should be able to go directly to our augmented matrix and just look at 32, 25, 520, 13, 17, 301, and we want to apply that to the reduced row echelon. If this was a test question, even if you were going to use the reduced row echelon form, I would suggest that everything that I wrote here is a good thing for you to write down because it shows me your organization. It shows me what your plan of attack is. And if I find that you missed something in the problem, I can go back and find out where you made your mistake and give you points for certain things. I'm the king of missed typos when it goes to a calculator. I don't do it on purpose, but that's going to kill me. That if this is a 10-point problem, it's going to take all 10 points away from me. But I go back and I look at this and it says, gee, did they set the table up like we wanted to? That's probably worth 2 or 3 points of the whole problem right there. Maybe 4 points. Because you probably can't work the problem very well if you can't get up this table, because it tells you what the system is. And then it tells you what the augmented matrix looks like. Now we should be able to jump to the calculator. So going to the calculator, we go into the matrix. We don't have a matrix that's defined exactly the way that we want it, but we know that we can reuse the matrix and just change its characteristics. So we're going to edit matrix A. How many rows? 2. How many columns?
3.
So does that look like the pattern that we see in our table? It's kind of like a template. So now what are the ingredients? 32, 25, 520, 13, 17, 301. Putting it in? Easy. Oh, I made a mistake. Always a good idea, like with stats, to go back and look and see, did you make a mistake up there? If I made a mistake, the arrow keys still work. I just go back, I don't have to clear this, I just type over the top of it. That should have been 25. So yeah, you are kind of responsible for dummy proofing it a little bit, error checking type of thing. But now it's in, quit, go back into the matrix menu, find the reduced row echelon form operation. And you got to be careful because the one above it in a hurry looks like it's the same thing, but that's not the same thing. That only reduces one row in your system. And you'd have to use that many times again, and that's not what we do. So reduced row echelon, applying it to the matrix number 1 where we stuck our information. And now we got to interpret these things. Now obviously they give us decimals, but notice what X and Y are talking about. X talks about the number of hours that we're going to get company A in, and Y talks about the number of hours for company B. And we want to keep 2 decimal places, so do we know that company A is going to get 6 hours? Because we have 6.00 up here, if we're only going to keep 2 decimal places, do we really need those 2 zeros? So 6 would be okay, right? Bottom one, are we okay dropping the 1, 1? Can we just use 13? No. They get 6 hours on the dot. These people get 13 hours and a little bit more, but we still have to worry about rounding off in there. So company B is going to get 13.11. If we go back to the program again then, firm A should be given 6 hours. I don't need the decimals, but firm number B should be 13.11. Now, whatever 0.11 of an hour is, in other words, they're going to get so many extra minutes in the hour, but they do 13 whole hours, and we still owe them a little bit of money out there. So obviously, I didn't make a mistake. Okay? you're going to see these table setups coming back. They're in the early part of the chapter, the early part of the unit. They're at the end of the unit as well, when we start dealing with the full-blown applications of all the pieces that we bring into play. But we're going to keep seeing this reduced row echelon. We're going to keep seeing this table set up for a lot of the problems that we deal with. Okay? So let's talk about what we were supposed